Okay, now we're going to do one more type of analysis. It's a structural analysis and it's a whole bunch of parts put together, and Inventor can do this in an interesting way. So you should just know there's a ton of stuff in it. There's all these skeleton files and assembly files and weldment files and sub files and old files. So it's the way Inventor works. You have to keep track of all those. You put everything in a folder, and then when you want to do something with it, you have to send the whole thing. So I downloaded that entire thing as a zip file. How do I do that? I just right click on this and I download. And it'll download all this stuff and it puts it in a zip file. Once it's in a zip file, it has to be gotten out of that because Inventor can't read inside of it. So I click on it, I extract all. That was a right click on it, extract all, and then just tell it to put it right next to it, extract all. And it'll do that. Okay? And there is what I got. Solar shade, and all that stuff is in there. So now I'll be able to get to it and find everything. So I am working on VMware, and so that folder is available to me through VMware. So I'm going to now open my assembly. Solar shade structure, well, probably going to be right in there. Nope. Now I have to find the darn thing. Upper and lower. Solar shade assembly, upper and lower. So I'm going to click on that, and there it is. There's a solar shade assembly. And I click on it, and there it is. Yay! It all showed up because it knew there's every single one of these things, like this assembly and this assembly have their own file, and in that file there's all the little pieces that go to it and all the cut lengths and everything like that. Okay, so then once I've gotten that one, I'm going to assign some constraints, and then I have to determine the magnitude of wind loads and add them as a distributed load. So I'm just going to show you how to operate this file, and in another one I'll show you how to do that. As a matter of fact, I might even have it on here, but we'll figure out what those loads are. So this is how it works, and now I'm going to do something. I'm going to go into environments, and I'm going to do a frame analysis. A frame analysis. And again, I create a simulation. Comes out on a different screen for me, so I'm always looking around for it. And oh, this is so cool. So here it is. And each of these things are joints. So I can fix certain spots. I can fix that one and that, and I can offset. Yeah, that's fine. Doesn't matter. I can fix that one and that one and that one. Those ones aren't showing up. Fix. Fix. There we go. Those are all fixed. I might get rid of that one and see if I can redo it without that weird offset thing. There it goes. So that means that they're in concrete or something and they're fixed. Now I need to put a load, and it's not just a force, it's a wind load. So I'm going to put a continuous load on that beam, and the wind load is probably not going straight down. It's probably, oops, I got the wrong one there. I want to go this one. It's probably going like something like that, blowing at it that way. And then if I think I can double click on it once I've got it in place, and I can say how big that is. 50 pounds per inch is pretty heavy. I'll leave it there just for now, but I can I can change them right in here. So there's that one. Now I'll put a continuous load on this beam. There we go. So that's going to be the wind blowing on it. And then if I come back in and double click on one of these arrows, I get my load, and that one says 50 pounds per inch also. So that's a humongous load. I'm going to guess it's probably going to be more like 4 or 5 or 10. Let me just actually change it. And I'll give you a load later. And now I should be able to simulate it. So it's got some wind blowing on it. And this pound per inch is sort of like a force acting into the solar panel that's on there. And it's going to be very much the same way. But you can see that these structural analysis looks a little different. So I'm still getting, it's pretty high. It's about 0.5. And so that's my displacement. It doesn't tell me, see what I can get out of my diagram. It gives me forces, stresses, displacement. It doesn't give me a safety factor. Okay, but I can find stresses if I want. Max, min, I'll look at my max. It's pretty low. It's pretty low. So I'm probably, stress-wise, I'm probably okay with this, but it's wobbling too much, even though it's got not that much stress. Okay, so this is how we would use it. And then in class, I'll demonstrate to you how we focus in and maybe change some of these sizes of these things to be able to do a little better, or even put another stiffening tie in it. Okay, so there we go. That's how we're going to use that last one, structural. The main thing is that you can get this one to work. Actually, it says that all I need to do is create the report. So that over here is create the report. I don't have to get this one perfect. I just need to create my report. Look at all this stuff that goes into the report. Somebody is going to read all this stuff, plug it into one of their calculation formulas, and do some additional work on it. Okay, so this is what an engineer would want as an output. So there we go. That's how we're going to do the frame analysis.